Hi student, to the second class of the foundation of classical electrodynamics. So, today we will continue the vector analysis that we started in the first class. This is class number 2. Okay, so we already know the few important properties of the vector that I believe most of the students are aware of, but still this is a refreshing kind of stuff we are doing. So, the next important thing regarding the vector is the vector multiplication. So, four kind of vector multiplication we can think of. So, one is scalar or simply dot product, which is if A and 2 are the two different vectors or same vectors, then we define this scalar product as A dot B. Next, vector or cross product. In cross product, we write this A cross B. Mind it, in the resultant of these things is a scalar. The outcome of this quantity is a vector. What is the third one? It is called scalar triple product. Where I have three vector A dot B cross C. Again, these outcome will be a scalar quantity. And finally, another kind of a vector multiplication one can think of, and that is vector triple product. These are the basic, I should say, these are the basic vector operations or vector multiplications. You can think of more complicated one, but if you know these four basic vector multiplication procedure, you can do whatever you want. This quantity should be a vector quantity. Okay. So, this four kind of vector product we will see that in this particular course in different cases it will appear, and then we need to execute these operations in different form. Well, after that I would like to introduce something very interesting, and that is called the Einstein summation notation. This is a notation, but very useful notation, or summation convention. So, what it says, so let me go back to the way I define the vector in this basis form. So, A can be written in this way. So, you can see we have a summation sign here. So, whenever we have a summation sign, and if we have indices here which is repeated, for example, here we have I and here also we have E I. So, we can remove this summation sign. So, I can simply write AI EI vector. I just simply remove the summation sign here, and it you can do that when you have a repetitive indices here. For example, here I and I both are there, these are repetitive. So, that means it is sum over repeated index. So, if I write this, that means already a sum is there, and I am just omitting this summation sign because the index are repeated. I can give you another example, and that is A dot B. This is essentially AI BI I 1 to 3. AI BI are the components, and this you can simply write in Einstein summation convention. It should be simply AI BI. Okay, next, again an important thing I like to define the Kronecker delta and another symbol, and that is called the Levi-Civita symbol. So, the Kronecker delta and Levi-Civita symbol, very important. So, let us understand what is this Kronecker delta. So, Kronecker delta, I already mentioned in the first class that this is my Kronecker delta, delta ij. And what is the beauty of this definition, or what is the property? Delta ij should be equal to 1 when I is equal to j. These two indices I and j, when they are same, then this delta should be 1. For example, delta 1 1 is equal to 1, delta 1 2, delta 1 1 equal to delta 2 2 equal to delta 3 3. This should be 1 because I and j are same here, and I can run 1 2 3, j can run 1 2 3. However, delta ij should be equal to 0 when I is not equal to j. If delta 1 2 I consider, if I consider delta 1 3, if I consider delta 2 3, these quantities should be equal to 0 because here I and j are not same. Okay, so this is basically the Kronecker delta by definition. Now, let us understand the Levi-Civita symbols. What is Levi-Civita symbols? Like Kronecker delta, we have here something called epsilon ijk. Previously, we have two indices, one I and j. Here we have three indices I, j, k. What are the properties? The properties are epsilon I, j, k it should be equal to 1 when I j k, which can take the value like 1 2 3 or x y z, if they are in certain order. For example, if I consider this as a x y z, then when it is x y z or when it is y z x cyclic order, or it is z x y. In terms of 1 2 3, if I write, it should be like when it is 1 2 3, when it is 2 3 1, and when it is 3 1 2, this value is 1. This value should take -1 when I j k are in opposite, in opposite orientation. And what is that? If it is y z x z y or y x z or z y x. So, if I draw, then things will be little bit clear. So, let me do that here. So, I am having x here, I am having y here, I am having z here, and they are forming a cyclic loop. Now, if I write it as 1 2 3, so 1 2 3 2 3 1 and 3 1 2, they are in this right hand cyclic loop, and then all the value of epsilon I j k should be 1. Now, if opposite happen, so if opposite happen, again I have x and y and z, and this value as usual 1 2 and 3, and opposite happen means x z y or y x z or z y x. So, in this case, okay, my here I am making a mistake, my direction should be opposite here because I am going in a opposite direction. So, it should be in this direction. And what are the values here? So, it is 1 3 and 2, and this is say 2 1 3, and this value is 3, y is 2 1. So, then epsilon I j k will take -1, but interesting, it will take 0 in all other cases otherwise. And what are the otherwise case? Because there are I j k, so it can be possible that j and k should be same. For example, x y y. So, if y y is there, then epsilon I j k should take the value 0. So, there are many combinations. So, these two combination, these 3 combination will give you 1, these 3 combination will give you -1, but all the other combination, when we have the repetitive value, for example, here x y z all are distinct 1 2 3 2 1 3, but if you have say 2 1 1, then this quantity will be 0. How many quantities will be there, that I want the student to figure out by yourself, that how many epsilon I j k value you can have when I j k can take 3 values. I can take 1 2 3, j can take 1 2 3, k can take 1 2 3, and you can now find out how many epsilon I j k, how many values are there. So, this is like a homework for you. Okay, so so after that we will discuss more about the properties and usefulness of these Levi-Civita symbols and delta functions, Kronecker delta functions, delta symbols. So, use of delta ij and epsilon ijk symbols. What are the use that that we are going to understand. So, first already it is mentioned that how for orthonormal basis ei dot ej we use this delta function, Kronecker delta symbols, epsilon ei dot ej is delta ij, already mentioned. Also another thing, for example, delta kk summation, k can take the value 1 to 3, this is a Dam indices and take 1 to 3. According to Einstein notation, I can remove these summation sign because we have a repeated index. So, simply delta kk. So, what should be the value of this quantity? K can take 1, k can take 2, k can take 3. So, it should be 1 plus 1 plus 1. So, it should be 3. Also, I define R is a position vector in the last class. This is a position vector, and this vector it is like x I plus y j plus z k. This is the way we normally define, but you can also define like x e I e1 y e2 x e I plus y e2 plus z e3 in general way, where e1 e2 e3 are the unit vectors. The same thing I j k, just the notation, there is a difference in the notation, but the things are same. Well, now if I make a derivative, for example, any component r j, so it should be simply delta k j, right. I already mentioned this is these things, and now component wise is this r j is a different component. Here this different component means I am talking about this x, y and z. So, that means r1 is nothing but x, r2 is nothing but y and r3 is nothing but z. Now, if I look carefully what should be the value of this derivative. So, and delta k 1 to 3 means this k is 1 means it is x, k 2 means y, k 3 means z. That means I am making a derivative, partial derivative with respect to x, y, z by taking the value of the this Dam indices k 1 to 3. So, 1 to 3 is nothing that it corresponds to x, y, z here. Now, if you look carefully that how these things is defined, that delta r1 plus delta x, this should be 1. So, here 1 and x, that is it is k is 1 and j is 1, delta 1 1. So, it should be 1. What about the other values k r 1 and delta y, that is this y is 2 here because this corresponds to 2. So, that means in this formula I have delta and k here is 2 and j here is 1. So, delta 2 1. So, that means it should be 0 and so on. You can please check it and you will find that this relationship, how this relationship is holds for position vectors. Okay. Also, summation of say V k delta k j. So, I multiply V k. So, k is a variable here, it can take say 1 to 3 and also j can take the value 1 to 3, but here k is repeated. So, I can using the Einstein notation, I can have I can have V k and delta k and j. J is a given value, k is changing 1 to 3. So, these value, if you look carefully, when k is equal to j, then only this is a meaningful. Now, apart from that, this delta value is always 0. So, that means it will give me the jth component of V. Okay. So, this is the way this delta one can use and one can operate. Now, try to understand the operation mechanism of the Levi-Civita symbol. So, we have the cross product A cross B, and if I want to find out this ith component of this entire vector quantity, then simply it is epsilon I j k, then A j B k. This is the way the epsilon operator, the Levi-Civita operator operates. So, you can find out A cross B, what we are having A cross B, I j k, A1, A2, A3, B1, B2, B3, these are the x, y, z component. I am just writing A1, A2, A3. What we have, if I want to find out the A cross B, okay, I find the 1, that means the x component. If I want to find out the x component, what we get? You will get A2, B3, B3 minus A3, B2. This is the value we are getting. Now, if I write in terms of these symbols, you can see that here j and k are repeated. That means the summation sign is already there. So, I am just removing this summation sign. So, j and k are repeating means you are changing this j and k to 1 to 3 and 1 to 3, but epsilon has this property that not all the values is 1, not all the values is 0, there are some values is are 1, there are some values which are minus 1 and 0. Now, if I put all these value together, you will find only non-zero value are epsilon 1 to 3. When I, j, k all are distinct, then only we have the non-zero epsilon value, and another term you will get epsilon 1 3 2, and you have A3 and B2. Why is that? Because according to the notation, is it epsilon I j k, j can take 1 2 3, k can take 1 2 3, but if j and k same, then epsilons are 0. So, all these values should be 0 when j and k are same. Apart from that, which distinct value it should take? I is 1 here. So, the distinct value 1 j and k are take when j is 2, k is 3, and when j is 3, k is 2. So, that 2 value I take when j is 2, k is 3, and when j is 3, k is 2. So, these two values combination we take and we will get this result. Now, if you look carefully, epsilon 1 2 3, this quantity is 1 plus 1. So, I should have simply A2 B3. What about epsilon 1 3 2? If you go back here and check that epsilon 1 2 3, epsilon 1 3 2, that is this one 1 3 2 first one, this value is minus 1. So, that minus 1 if I put, so it should be simply minus of A3 B2, which we already had here. So, this is the way we can define the cross product in terms of this Levi-Civita symbol epsilon 1 2 3, very powerful and very useful. Now, few more things. Okay. So, delta I j epsilon I j k, what value we will get? Now, you can see this is a very interesting kind of problem. So, you can see that I and j and k here. So, when delta is non-zero, then I and j should be same, but if I and j is same, then epsilon is always 0. So, that means this value should always give you 0. Another problem, what value of epsilon I j k and epsilon I j k multiplied by when I j k are varying. Again you will going to see that there are different combinations for which epsilon will be 0, because when j and k are same, I is changing 1 to 3, j is changing 1 to 3, k is changing 1 to 3. Only the meaningful value you will get that when they are distinct, and in that case you will find this value. If I add, because there is summation over that, because these are the repetitive index. So, you will see that these values should be equal to 6. Well, also with these notations you can find something. For example, A cross B, and we know that it is minus of B cross A, right. So, now we will going to prove this using this Levi-Civita symbol. So, A cross B, I need to put the vector sign here, ith component, it is simply epsilon I j k A j b k, that is the way one can have. Now, I can manipulate this right hand side. Let us write epsilon I j k b k A j. Now, I change this k to, I can write it in this way, I just can change this k to this form, usual form j, and k j to k. If I do, then I should write epsilon, I replace this j I is there, I replace this j to k and k to j, because these are the damming. I can have b j and a k. Mind it, I replace j to k here and k to j here. K is replaced by j, j is replaced by k, because these are the damming. I can always do that, interchanging. Now, I have I k j, right. I now write it in a proper way. So, if I write epsilon I j k, I need to put a negative sign because I am changing this order. So, b j a k. So, now these things are now following whatever the cross product symbol is there. So, this quantity is minus of b cross a with ith component, okay. Because if I write b cross a in epsilon symbol, it should be epsilon I j k b j a k. So, in order to have this form, I just manipulate it and find that a cross b ith component is simply b cross a ith component with a negative sign, and that we know. Okay, now I am giving a 2 homework problem and then I will complete this class. So, these are the homework problem. So, the problem is using symbol show that. So, you need to use Levi-Civita symbol to show one these two vector identity, A cross A 0, and second this big identity A cross B dot C cross D is equal to, you need to prove it, A dot C and then B dot D minus A dot D and B dot C. So, these two problems I like to give you student as a homework. So, I believe you can do this problem by using these symbols. Please go through the class very carefully. These whatever the steps are done, all the steps is there, and I like to give you these two simple problems to check whether you can use this Libby beta symbol and delta symbols, Kronecker delta symbol properly to find out this. Once you know, once you understand these symbols, the important thing is that once you understand these symbols, you do not need to remember these complicated vector identities. You can, whatever the vector this kind of problems is given to you, by using these Libby beta symbols you can find it out by yourself. You do not need to remember anything, these big expressions. So, with this note I would like to conclude here in today's class, because I do not have that much of time to continue. In the next class again we try to understand the concept of Libby beta symbols and try to solve few other vector identities like the triple product identity and others identity. So, thank you for your kind attention. So, let us meet in the next class and do more about this vector analysis. Thank you.